Listening, fill in the blanks.
Let's start.
Bone tissue is constantly being remodeled, meaning that bone is added or removed, depending on nutrient availability and the stress that the bone is under. Female polar bears, however, undergo extreme conditions during every pregnancy. Once autumn comes around, these females will dig maternity dens in the snow and will remain there throughout the winter, both before and after the birth of their cubs. This process results in about 6 months of fasting, where the female bears have to keep themselves and their cubs alive, depleting their own calcium and calorie reserves. Despite this, their bones remain strong and dense.
As for emotions, while the evidence is once again anecdotal, many bears have been seen to hit out at ice and snow, seemingly out of frustration, when they have just missed out on a kill. Moreover, polar bears can form unusual relationships with other species, including playing with the dogs used to pull sleds in the Arctic. Remarkably, one hand-raised polar bear called Agi has formed a close relationship with her owner Mark Dumas to the point where they even swim together. This is even more astonishing since polar bears are known to actively hunt humans in the wild.
We know that the creation of wealth, for example, depends not only on an adequate supply of useful ideas but also on the availability of other, more conventional factors of production, like capital and labor. Similarly, prosperity, stability and justice usually depend on the resolution, or at least the containment, of major political struggles over wealth and power. Yet within our economies, ingenuity often supplants labor, and growth in the stock of physical plant is usually accompanied by growth in the stock of ingenuity. And in our political systems, we need great ingenuity to set up institutions that successfully manage struggles over wealth and power. Clearly, our economic and political processes are intimately entangled with the production and use of ingenuity.
We tend to make it more complex. Many of the natural systems critical to our well-being, like the global climate and the oceans, are extraordinarily complex to begin with. We often can't predict or manage the behavior of complex systems with much precision, because they are often very sensitive to the smallest of changes and perturbations, and their behavior can flip from one mode to another suddenly and dramatically. In general, as the human-made and natural systems, we depend upon becoming more complex, and as our demands on them increase, the institutions and technologies we use to manage them must become more complex too, which further boosts our need for ingenuity.
Much of the early work for simplicity ignored the fact that water in the oceans moves in 3 dimensions. By movement, of course, scientists don't mean waves, which are too small individually to consider, but rather movements of vast volumes of water in huge currents. To understand the importance of this, we now need to consider another process, advection. Imagine smoke rising from a chimney on a still day. It will slowly spread out in all directions by means of diffusion. With a strong directional wind, however, it will all shift downwind. This process is advection, the transport of properties, notably heat and salinity in the ocean, by the movement of bodies of air or water, rather than by conduction or diffusion.
Massive ocean currents called gyres do the moving. These currents have far more capacity to store heat than does the atmosphere. Indeed, just the top 3 meters of the ocean contains more heat than the whole of the atmosphere. The origin of gyres lies in the fact that more heat from the sun reaches the equator than the poles, and naturally, heat tends to move from the former to the latter. Warm air rises at the equator and draws more air beneath it in the form of winds, the trade winds that, together with other air movements, provide the main force driving the ocean currents.
The role of packaging is likely to be very different for each of these types of decision-making. Under heuristic processing, for example, consumers may simply need to be able to distinguish the pack from those of competitors since they are choosing on the basis of what they usually do. Under these circumstances, the simple perceptual features of the pack may be critical, so that we can quickly discriminate what we choose from the other products on offer. Under systematic processing, however, product-related information may be more important, so the pack has to provide this in an easily identifiable form.
There is considerable debate over how we should react if we detect a signal from an alien civilization. Everybody agrees that we should not reply immediately. Quite apart from the impracticality of sending a reply over such large distances at short notice, it raises a host of ethical questions that would have to be addressed by the global community before any reply could be sent. Would the human race face the culture shock faced with a superior and much older civilization? Luckily, there is no urgency about this. The stars being searched are hundreds of light years away, so it takes hundreds of years for their signal to reach us, and a further few hundred years for our reply to reach them.
If you go back far enough, everything lived in the sea. At various points in evolutionary history, enterprising individuals within many different animal groups moved out onto the land, sometimes even to the most parched deserts, taking their own private seawater with them in blood and cellular fluids. In addition to the reptiles, birds, mammals, and insects which we see all around us, other groups that have succeeded out of water include scorpions, snails, crustaceans such as woodlice and land crabs, millipedes and centipedes, spiders, and various worms. And we mustn't forget the plants, without whose prior invasion of the land none of the other migrations could have happened.
Japan has a significantly better record in terms of average mathematical attainment than England and Wales. Large sample international comparisons of pupils' attainments since the 1960s have established that not only did Japanese pupils at age 13 have better scores of average attainment, but there was also a larger proportion of low attainers in England, where, incidentally, the variation in attainment scores was much greater. The percentage of gross national product spent on education is reasonably similar in the two countries. So how is this higher and more consistent attainment in maths achieved?
Like, share, subscribe the channel and press the bell icon for further updates.